Hello, you're welcome back. All right, so we'll continue from where we stopped. We are going to be looking at geometric progression. All right, so now the difference between geometric progression, of course, abbreviation is GP. All right, and the arithmetic is that for an arithmetic progression, two consecutive terms in that sequence actually differ by a common difference. Okay, but in geometric progression, two consecutive terms differ. Please, two consecutive terms. All right, terms. All right, two consecutive terms actually differ by a common ratio. Now, this example here, okay, I have two, then the next term is four, the next term is eight. So, of course, you know that this is not a common difference. I am not adding to get the next term. All right, it's called that this rule, I actually multiplied two by 2 to get 4. Then I multiply 4 by 2 to get 8. I multiply 8 by 2 to get 16. Okay, so which simply means that for me to get the next term, and the next term will be 32, 64, so on and so forth. Okay, so this simply show that for a a geometric progression, what we have is common ratio, not common difference. All right, common ratio, and we use the symbol R. So how do we get that common ratio? We get the common ratio by dividing the two consecutive terms. Okay, so that's for the common ratio is going to be equal to 4 divided by 2, which is still equal to 8 divided by 4. Is still going to be equal to 16 divided by 8, and everything will give me 2. So that's a common ratio for all the terms in that GP. All right. So because of that, now you know it is very much easy to predict what the next term will be. Okay, by multiplying the previous term by the common ratio. All right. So now, as we normally do, we can't go by getting to, add or multiply the previous term to get any number of term that we are looking for. For example, if I want to get the next term, that should be 128. Okay. What if we are being asked to find the hundredth term? Okay, that will be very very it will be so cumbersome for me to keep on multiplying the previous term by the common ratio to get to that particular number of terms. So I'm going to give you a formula for the nth term. Okay, nth term of a GP. So this formula of nth term of a GP will help us find any number of term. All right, so it goes this way. The nth term Tn is given as AR raised to the power of n minus 1. Of course, you know what the A is, all right? The A is the first term. The first term. The R, you know what that is already? That's the common ratio. All right? And the N, of course, that's the number of terms you're looking for. Number of terms. The number of terms you're looking for. All right, so let's actually uh, prove our formula, right? Now, let's look at if the our formula will be able to yield this term. This term is 1, 2, 3, 4, 5, 6, 7, the seventh term. Let's see if our formula will yield this seventh term for us, 128. So that means T7 is equal to the A is the first term. The first term is 2. Then multiply by the first term is 2 multiplied by by the common ratio, which of course is also 2. Then the rest of the power of n. I'm looking for that the seventh term, n7. Then 7 minus 1. All right. So if we should go by this, I'm gonna have 2 times 2 raised to the power of 7 minus 1 is 6. Okay, let's do this. So this is gonna be 2 times 2 raised to the power of 6 is 64. Do that 2 times 2 times 2 times 2 times 2 into 6 times, that's gonna be 64. Okay. Then of course 2 times 64, that's 128. That have actually proven that my formula is valid. Okay, so please take note of that. Now, the next step is for us to get, okay, uh, express the formula of sum of n stem of a GP, the sum of the n term of a GP. All right, now the formula for the sum of the n term of a GP xn is in 2 dimension. What do I mean by 2 dimension? Okay, I'll use one. I'll use it, one of it, okay, depending on some conditions. All right, now I'm going to give you the two formula. Xn is given as A, A, bracket open, R raised power n minus 1, bracket close, all over R minus 1. This is one formula, okay? And that way of expressing it is also like this. Xn equal to A. Now this time around, 1 comes before the R raised power n, all over 1 minus R raised power n. So now it's still, when do we use Formula 1 and when do we use Formula 2? Now you use Formula 1 when your common ratio is greater than 1. Okay? That's why you use Formula 1. But if your common ratio is greater, okay? If your common ratio is greater than is less than 1, please pardon me. It's less than 1, you use Formula 2. Okay? For example, now let's say I want to actually find the sum. I want to find the series of first four term of this particular sequence. That's S4, right? That's 2 plus 4 plus 8 plus 16, okay? I will definitely need a calculator, so let me get a calculator. All right, so I'm gonna have 2 plus 4, 2 plus 4 plus 8 plus 16. Of course, what's what's it giving me? That gives me 32. That's giving me what, 30? Okay, yeah, 30. The sum of the first one, two, three, four, first four terms is 30. So, and let's actually use our formula to prove this. So, x4 of that GP above. Now, the question is, which formula am I going to use? Am I going to use the first formula or the second formula, right? So I'm going to use the first formula. Why? Because the common ratio of this sequence is greater than 1. Because the common ratio is 2. 2 is greater than 1. The common ratio is 2. Okay, so that simply means that the common ratio is greater than 1, right? So I'm going to use this formula. So let's start putting the value. The first term is 2. Then the common ratio is 2 raised to the power of the nth term. That's the fourth term. Then minus 1 divided by 2 minus 1. Let's see how that goes. Oh, please, the common ratio, I have not put the value. The common ratio is 2. Okay, so that's 2 raised power 4. Okay, let's see how that goes. That's going to be 2 bracket open. 2 raised power 4 is 16. Okay, then minus 1, then divided by 2 minus 1 is 1. So this is going to be equal to 16 minus 1, that's 15. Okay, and 15 times 2, that's going to be 30. So that actually confirms our formula, all right? But the question is, I know someone that is in someone's mind is, okay, which instance do we actually use this formula? I'm going to give you the instance, all right? Let me clear up. Let's look at a situation where you're being asked to, okay, find the sum of the first four term of the series of this particular sequence 1 all over 2, comma 1 all over 4, comma 1 all over 8, 1 all over 16, dot 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 dot, it continues, okay? So as you if you are as you see this now, it's called at the common ratio here. If I should find the common ratio, okay, just in case you don't know how to, uh, you're confused about the common ratio, you actually use the formula for common ratio. Divide this term by this, okay? So I'm dividing 1 all over 4 divided by 1 all over 2. Of course, you know how we do division and fraction, okay? That's going to be 1 all over 4. Then I change the division sign to division sign to multiplication times. Then I have to invert the divide, so 2 will come up. That will be 2 all over 1, right? So 2 cancel itself 1. Divide 4, that's 2. So that means my common ratio is 1 all over 2, half. And you can see now from what I have here, the common ratio is less than, is pretty much less than 1. Okay, it's less than 1. So that is when I will apply the second formula. Okay, so for me to find the sum of the very first fourth term of that particular sequence, I'll use this the second formula. Please pardon me, the second formula here. All right, so that's gonna be a. My first step is 1 all over 2. Bracket open 1 minus my common ratio is 1 all over 2. Don't forget, I have to raise it to the power of 4. Okay, then divided by 1 minus 1 all over 2. Okay, so let's simplify that. How do we simplify that? Okay, all right, so this is going to be 1 all over 2. If I open the bracket, 1 minus 1 raised to power 4 is 1, okay? Then, of course, 2 raised to power 4 is 8. Bracket close. 1 minus 1 all over 2. So I have to simplify the fraction, okay? The fraction inside the bracket. How do I do that? That's going to be 1 all over 2, right? The LCM of this fraction inside the bracket is 8. Of course, 8 divided by 1 is 8. 8 multiplied by 1 is 8. Minus 8 divided by 8 is 1. 1 times 1 is 1. I close that. The same thing happens here. The LCM is 2. Okay? 2 divided by 1 is 2. 2 times 1 is 2. I bring the minus. 2 divided by 2 is 1. 1 times 1 is 1. Okay, so this is going to be equal to 1 all over 2. Bracket open. 8 minus 1 is 7. Then 7 all over 8. Okay? Then, of course, divided by 1 all over 2. Of course, you know what happens here also. Okay? You know exactly what happened here. If I open this bracket, I'm gonna have 1 times 7, that's 7. And of course, 2 times 8 is 16. Then, of course, divided by 1 all over 2. So, working on this is going to be 7 all over 16, then times 2 all over 1. Okay? So, 2 divided 16, I have 8, divide 2 divided itself 1. So I'm gonna, the final answer is gonna be 7 all over 8. Okay, so that is the sum of the first four term of that GP. Okay, so I hope that is well understood. All right, and there's just one last formula I need to actually introduce here for a GP. Okay, that is what is known as the sum to infinity. Sum to infinity. So if you are being asked to sum to infinity, that means you have summing to, of course, to a point, to a place where the value is undefined. All right. So let's say you have a GP, okay, like what I gave you before, 1 all over 2 minus 1 all over 4 minus 1 all over 8. Then it continues till infinity. This is the symbol of infinity, right? So the sum to infinity, the formula for to sum to infinity, the sum to infinity, x infinity, okay, of a GP is given as a all over r minus 1. Simple. And they use this formula, okay, if r is greater than 1, or the sum to infinity is equal to a divided by 1 minus r if r is less than 1. So in this case now, which formula am I going to use? I'm going to use the second formula because r is less than 1, right? So so the sum to infinity of this sequence is going to be equal to, the first term is 1 over 2, then divided by 1 minus r. And of course, the common ratio is 1 over 2. We've done that already, okay? So this is going to be 1 over 2, of course, divided by, let's simplify the this fraction. The LCM is 2, right? 2 divided by 1 is 2. 2 times 1 is 2 minus 2 divided by 2 is 1. 1 times 1 is 1. Okay, so let's proceed. So I'm going to have 1 all over 2 divided by 2 minus 1 is 1 all over 2. So that's going to be equal to 1 all over 2 times 2 all over 1. So when I divide that, that will give me 1. Okay, so that is the sum to infinity. There's a lot of questions that we can solve on that GP and AP. Okay, so we are going to be looking at examination question in the next video. All right, see you in the next video. Thank you very much.